let me take this opportunity now to introduce Mbeo Ogea, who works with the Stockholm Environment Institute, because he'll be our next speaker. And maybe he'll tell us maybe much about himself. And then the floor is yours, Mbeo Ogea.
Good morning, everyone. I hope you are able to hear me clearly. Can I get a sign?
Yeah, sure.
Thank you. So my name is Mbeo Ogea. I work for Stockholm Environment Institute as a researcher in the Energy and Climate Change program. My specialty is on energy systems models and renewable energy technologies. But I also cross-cut in the areas of climate change and air pollution, because these are related activities. Ideally, it wasn't me who was supposed to present, it was Andiana Mbandi, but because of engagement, I'll be presenting the work that we are doing in, at Stockholm Environment Institute. Are you able to see my screen?
I am able myself.
Okay, thank you. If you are able, then I believe everyone else is able. Yeah, so I'll try and run fast through the slides. But basically, our work in, on climate change and air pollution is a partnership project that, a partnership program that we are running with the Directorate of Climate Change and Nairobi County Government. With the Directorate of Climate Change, our first instance is to work with them in assessing the recently developed National Climate Change Action Plan 2017-2022, and look at the various mitigation actions that have been proposed and assess on the potential of achieving the proposed mitigation targets. With the Nairobi County Government, we are again working on air pollution, looking at the short-lived climate pollutants and other air pollutants within the city of Nairobi, looking at using two different approaches, model-based approach and a participatory mapping approach. All these two activities or two projects are ongoing, and I'll be presenting on one of the tools that we are using in doing this, and also maybe preliminary findings. So basically, I want to bring us back to the basic concept of air pollution and looking at both urban and rural areas. The various sources of these air pollutions in the rural areas coming from solid biomass burning, children playing, kerosene burning, and household-related pollution that gets its way into the ambient air, and also kiln production or brick production or charcoal production from kilns. And in urban areas, mostly it's industrial and road traffic. That is the vehicle emission or the transport sector, but also the substantial waste emissions from solid waste dumping and liquid waste effluents. Basically, the attention is brought into the number 4, the transport emission. And in the morning, sometimes that kind of dark smoke is observed. And look at the type of vehicles in the number 4. We have old vehicles, some of them running to a range of over 40 years, which is not the real or the ideal lifetime of a vehicle. So you can imagine if the optimum lifetime of a vehicle is 18 years, beyond that, how the engine performance will be and what level of emissions will be. In solid waste management, number 5 is characterized, it's a more characteristics of Dandora landfill. If you go there, this is the exact scenario that you would see, because the smoke all through because of the burning of the solid waste, scavenger birds, people interacting at the same time, and all this interacts with people. But I don't want to spend so much time on that, or rather spend so much time on this background information, because most of them is within the literature. Whereas we know that agriculture and forestry are main contributors of greenhouse gas emission, but the transport sector and also the industrial and household energy sector are very key elements in contributing to the various short-lived climate pollutants that we are looking at here. And the action plan gave this type of map and projected to show the level of greenhouse gas emission by 2030. But the question is, how is life impacted? Or what are the numbers in terms of the premature deaths? So the indoor air pollution is the greatest cause of premature deaths. And we are trying to get towards this. But ideally, there's also a lot of people dying from the ambient air. Most of the times we report the number of deaths in road accidents and other diseases. But the attribution to air pollution, the deaths resulting from the air pollution that we could avoid, is not often spoken. And this is where the health department and the policymakers need to look into. Now, looking at what are these short-lived climate pollutants, maybe for the people joining and for the people hearing this for the first time, and how is it related to greenhouse gas? So basically, these are emissions which are either local or take shorter duration of time to be in the air, but their impacts are quite dire. Now, take a case of black carbon. Black carbon can be sourced from agricultural waste burning, from industrial emission, from vehicle emission, and from household energy use, that's traditional biomass use. And it's mainly local. It's mainly within the area that it's burnt, or from within the area it's sourced. It doesn't go so much into the region, into the global level. And it takes just number of days before it settles down. Methane, mainly from enteric fermentation and agricultural activity. It takes around 12 years. So it's also a long-term, it's also sometimes classified as a source of greenhouse gas emission and converted into greenhouse gas equivalents. The tropospheric ozone takes weeks within the atmosphere and also comes from the industries and the transport sector and several laboratories and agricultural fields, and also affect the location or local impact. It's not transported so far from where it's emitted. And that's why they are very important when it comes to analyzing these types of air pollution and the impact of the health or the livelihoods of people within the near proximity of where these emissions are emitted. And the hydrofluorocarbons mainly are long-term greenhouse gas emissions, and it's transported far and wide into the global scope. So today's focus, as I was made to understand, is on the transport. And putting it into the context of the work that we are doing with the Directorate of Climate Change, it falls within the priority number 7B, that's the transport mitigation. And they've, we are using a low emission analysis platform with integrated benefit calculator to help us understand the level of emission, both greenhouse gas and other emissions, that's black carbon, PM2.5, and organic carbon. and we can as well analyze several other emissions. So how does the tool work? The tool first get to understand the emission sources, and we get the emission and the mitigation scenario, and it applies atmospheric transport and concentration, and attributes the emissions or the concentration of emissions to human health, to rise in global temperature, and to crops or to agricultural productivity. So that's the overall build-up of the tool. But getting into the first principles of its operation is that if you are looking at a car emits through exhaust several gases. It could be carbon dioxide, hydrocarbons, particulate matter, black carbon, sulfur dioxide, volatile organic compounds, carbon monoxide, and nitrogen oxide. After burning diesel, or diesel burns in the presence of air to produce those types of emission. But then it reacts with the UV light to generate tropospheric ozone, whereas black carbon hangs and combines with also other gases to impact on the area or on the proximity sources, where proximity areas of livelihoods within the area where it's emitted. So in a more detailed way, how we build our model is first to understand on the demand of energy within the global or a national scope, regional scope, or a county scope. So for example, if you want to know within the transport sector how much energy is demanded or how much fuel is demanded, is we know that the final energy intensity is built by the total number of vehicles multiplied by the percent share of the vehicle category, multiplied by the engine efficiency, and by the distance traveled by that vehicle, and the energy intensity per kilometer traveled. That gives you the total energy that is consumed within that vehicle category. It can be cars, it can be light commercially vehicles, urban buses, or it can be heavy diesel lorries. And for each of them, we multiply by the emission factor for the various engine type. Like the previous panelists talked about Euro 1, Euro 2, Euro 3, Euro 4, Euro 5, and Euro 6 level of engine types, depending on the efficiency. So if we are still using the uncontrolled, because some of our lorries are dated back to almost 30 years ago, and most of them probably are still using the uncontrolled types of emission levels. Yeah. And if that gets into the atmosphere, then it has more impact than using the modern types of engine. What type of data do we input in this model to give us this kind of result? At the activity level, we input the fleets. That's the number of vehicles. For example, in these, we've highlighted the heavy duty vehicle. So the cumulative number of registered vehicles within the country or within the locality or within the area of the study. Then the final energy intensity, that's the fuel use or the fuel economy for that particular type of vehicle. And then if you are doing cost analysis, you can also include the demand cost. That's the cost of adding new type of vehicle. If you are doing a scenario of from less efficient vehicle to a more efficient vehicle, then you can do that and optimize and know what will it cost us to achieve these mitigation measures. Then we entered the road emission factor, the fractions of unpaved roads where the vehicle is driving on, because these SLPs also include the dust particles in the air. So if most of the roads are untarmac, then those loose particles that will be flying into the air are also contributors to the emissions. And proportion of fleets on the road per day. For example, if within Thika Road we have 500 long buses, not all of them will be on the road at any given day. There's a proportion that will be in the garage, some proportion will have worn out. So we input all that, yeah? And we also understand the distance traveled in an annual time scale for every vehicle. Is it like, for example, for heavy duty vehicles, in our model, we had a calculation of 55,334 vehicle kilometers per vehicle within that, this is a national, region is Kenya, within the country. So that's the kind of information that we enter. And in simple, if I recap, emission is equal to the number of vehicles by mileage by the emission factor, and give us the various types of emissions. So we need to know the various emission factors for all the emissions that are being generated from the types of vehicles to help us understand these emissions. So, well, I'll skip this because this is basically what I've tried to explain before. First, how LEAP works, it collects data for energy and non-energy sources, where the activity data by sector, in this case, the transport sector, how many lorries, how many cars, and then it calculates the emission by the default emission factor. And this is where we have one of the challenge at the moment in our project, because we are still using default emission factors. If we would get the localized emission factors, then our results will be quite relatable and will be very informative. Otherwise, the results we are getting now are for decision and policy making. Using international data sets, this is the level of emission that we are probably experiencing in the country, but it doesn't give the actual local context. And then we create the emission scenarios that's reducing based on the key drivers like GDP, population growth rate, and so on and so forth. And then the tool is connected to the gains XLEAP of GeoSchem adjunct model that concentrates the emission at every grid square, and also related to the population within that grid square. There is we could have so much emission, but the population is very low. So the level of impact of that emission within that area will be lower than so much emission in Nairobi, where the population is high. And then we estimate, yes, we concentrate, and then we relate to the exposure level. So at the moment, we can only be able to estimate human health or health impacts of PM 2.5 and ozone deaths. Yeah. We've not done black carbon, the impacts of black carbon on human health. We've done PM 2.5. Crop impacts on rice, wheat, soya, maize yield, and reduction due to ozone, climate change impacts. So a study done by my colleague, that's Andiana Mbandi, tried to project the future population of vehicles. Ideally, it's a little bit challenging to project the vehicle population in the country based on the vintages. That's the year of vehicles and the optimum lifetime of a car. Because ideally, we should say that by 18 years, this particular vehicle should not be on the road anymore. And it doesn't work so well in Kenya. For example, if I can relate to myself, my X-Trail is KBL and it's a 2004 model. So in the next 3 years, I should say that it should stop being on the road. I'm not sure if I'll be able to keep that to come to a reality. But if it will still be working well and it can run on the roads, probably I'll still put it on the roads. How many KAZs, KBAs, KBCs are still on the roads, KAW? there are so many vehicles which are unroadworthy and are still on our roads. So the population grows high and the emission intensity increases. In the urban scale within the participatory mapping, we try to observe where are there congestions of vehicles. That's where are there mainly road traffic. So you can see that as you get to the CBD, there is so much congestion over there. And unfortunately, this is the area where there are 4 million people going into the CBD on a daily basis. And that's very, very, very high. So those are the background that result to the activities that we are doing with the Ministry of Environment and with the Nairobi County government. Getting a little bit more into the details of the SLCPs and interrelating with what types of vehicles result to what, you can see heavy duty vehicles contribute to about 25% of CO2 and 22% of PM2.5 and 30% of black carbon. If I were a decision maker, that will be an area of interest for me to know how would I reduce this emission from the heavy duty vehicles. Is there some regulation that can be enforced to reduce on these emissions? Then again, looking at the motorcycles, they are growing very rapidly and they are becoming a common means of transport or mode of transport. And they are main contributors to PM2.5. And this is also an area of concern. And if I go back to the previous chart and look at the growth population of the various types of vehicles, motorcycles projected to grow very high. And that's a cause for worry for a policymaker. So within the National Climate Change Action Plan, there are key strategies of emission mitigation. That's introduction of SGR from Nairobi to Mombasa should be electrified. 30% of freight from Mombasa to Nairobi shifted from road to rail. That one already takes care of the heavy commercial vehicles. Roadmap for the improvement of heavy duty truck efficiency developed, including increased use of low rolling resistant tires, supernatural fittings, etc. Light duty vehicle fuel economy improved through labeling, promotion of fuel efficient driving, and improved traffic management. 70 kilometers of BRT for Nairobi metropolitan area. Use of electric hybrid SGR extended to Nairobi, from Nairobi to Naivasha, and should also be electrified. Feeder public transport to BRT, 150 kilometers of non-motorized transport. So these are a handful of strategies that the county government or the national government would like to achieve within the strategic mitigation action within the 5-year period of a strategic plan. And at the moment, we're still working on this, it's still work in progress, but we've implemented heavy duty truck efficiency and 70 kilometers of BRT within the Nairobi metropolitan. Yeah? And just a glimpse of the result that we'll be expecting is if we implement this partial, the very minimum that we've implemented in the model, that's heavy duty truck efficiency and 70-kilometer BRT Nairobi metropolitan, then by 2030 we'll be avoiding almost 2 million tons of carbon dioxide emission. And looking at the various short-lived climate pollutants, we'll be avoiding about 1.5 1,500 tons of particulate matter PM2.5 and another 500 tons of black carbon. And mostly because we've only implemented the freight. We've not implemented anything on the passenger. Of course, we've done the 70 kilometers BRT. 70 kilometers BRT compared to the massive number of vehicles within our national roads, it's very negligibly indicated or shown in our result. So this is where we are, and we are going on to do our analysis. And in conclusion and way forward, we can say that we are using an integrated approach that includes greenhouse gas and short-lived climate pollutants to analyze mitigation options. And there is high potential in avoiding air pollution. Like just from what you've seen, we've only implemented very little, but there is some result that can be shown in the charts. So if we could implement all the 9 strategic actions as listed by the National Directorate of Climate Change, then we could see much more aggressive and real avoidance, emissions avoidance. But however, there are some data gaps, and most importantly is the local emission factor. It's still unsure who, or if we have laboratories, or if we have facilities. NAMATA was supposed to do some of these emission measurements, randomly sample vehicles and do the emission measurements. But this is an information that is not yet available, or it's not been done yet. And then we continue and proceed and do the estimation of benefits in terms of avoidance of death and agricultural productivity, or the impact of these emissions in agriculture, and also the mitigation action. So these are information or the results that we should be presenting in the next 1 or 2 months. So that's it, and thank you for listening.
Thank you very much, Mbeo. I believe that we have really been fed with quite a lot of knowledge and information. And I believe that we can make better decisions if we can maybe follow the recommendations that you have given. The work that the Stockholm Environment Institute is doing is quite brilliant. And as I welcome questions, so there is one comment from one panelist that says that he believes that a 20-year-old well-maintained vehicle actually would emit less emissions compared to a 2-year-old new but poorly maintained vehicle. What is your reaction to that?
Okay, yeah, thank you. Ideally, the panelist is right. If you buy a vehicle and you don't maintain it, it will even crash before the 2 years period end, and its emission will be pathetic. And that's why NAMATA, I think, it is happening for the commercial vehicles, but it's not happening for the private vehicles, where annually you have to take your vehicle for inspection. Yeah, because it should be a regulation that everyone maintain his vehicle, or everyone do maintenance of his vehicle. So we don't expect this so much, of course, because in our assumption, we would assume that even however best you can, there's always a lifetime for any mechanical product. However best you can maintain your vehicle, but a 20 years lapse or a 20 years maintenance period, you'll also realize that even the maintenance cost is much more than maybe changing all over your engine. But yeah, these are mechanical facts that I don't know if I'll want to agree that we can still maintain the vehicles after 20 years and still get low emission compared to a vehicle that is well maintained in 2 years. But I want to dispute that you should not stop maintaining your vehicle. You are muted, Dr. Muta.
You also asked whether the VMT you included in your analysis estimates, were they estimates or actual measurements?
Sorry, come up again.
Were the factors you included in your presentation for the vehicular emissions, were they estimates, analysis estimates, or they were actual measurements?
No, these ones were actual default estimates, not national measurements. Yeah.
Okay.
Yes, actually from the international literatures of emission factors.
All right.
Sorry.
And that's why we say that it's a challenge, because emission factor obtained from Japan or from UK after testing their heavy-duty truck vehicle will not be the same as the emission factor of the engine of a poorly maintained heavy-duty truck vehicle in Kenya. So we don't have local emission factors.
Okay.
Sorry, just to clarify, Beo, if I could just very quickly, this is not about the emission factors, but the activity data, and specifically the VMT, vehicle miles traveled. Were those estimates or were those actual measurements? And if there were measurements, how did you do that?
Yes, those ones were actual measurements. Now, this is an elaborate study that my colleague did, Andiana Mbadi, and she used mixed method of qualitative and quantitative data. And the quantitative data, she actually traveled with some of the vehicles, because it was a PhD program study, traveled with these vehicles, and then also asked the vehicle owners how many trips you make in a day. So with the kilometers they cover, taking the measurement directly from her kilometer tracker, she could estimate then the vehicle kilometers, yeah, that will be covered in a day. So if you can be able to measure the actual kilometers covered in a day, and then you verify with also the qualitative information that she got, and some questionnaires that she delivered. But also we also got data from the Matatu associations, yeah? The Matatu associations, giving us the number of fleets they have, the kilometers they or the number of trips that they make per day in every given route, and the number of vehicles that are there on a daily basis for a period of 1 month. Then you can be able to know also the proportions of vehicles that will be on the road at any given time.
Oh, thank you very much, Beo. There's another one that is asking that can the low emission actions for the pollution model be used for local analysis? I'm just reading it. I don't know whether the question is clear, but perhaps Dr. Mutai, can you re-ask this question?
Sorry for type. Can the LEAP model be used for a local analysis? Because in Beo, during your presentation, you said it's for the national. What I'm asking is, can it be used for a local analysis? Thank you.
Yes, currently it's been set to be used for national analysis. Because especially when you're doing the concentration, you can analyze the emission within the county or within whichever sub-national level you want to do your analysis. But we cannot be able to concentrate the emissions and relate it to the human health and other impacts. because of the grid square. Yeah? Right now, the grid square is using the GHG adjoint model is 250 kilometers by 250 kilometers. To analyze a small location is like we need to have, like the one for Nairobi we intended to do, is to have a 25 kilometers by 25 kilometers grid square. So we concentrate the emission within that small grid square and then relate it to the population within that small grid square, and then now attribute to the health impact of the population. But that has not yet been developed. But in the national context, we can analyze including the health impacts, because it's a big grid an analysis which has already been developed by GHG adjoint models. So the answer to your question, nationally, yes, we can be able to analyze both emission and concentrate the emissions and relate it to health impacts. But locally, in terms of the urban level, we can only be able to analyze the emissions, but we cannot be able to analyze the concentration and the health impacts. Does that answer your question, really?
Yeah, thank you. Yes, thank you.
Okay, thank you very much, Mbeo. Then there's another question that a keen eye was looking at the death from indoor pollution, which was significantly high from your presentation. And now the question is, how did you obtain this data?
Well, this is not our result. This is our World Health Organization result. Yeah. So it's actually, we are yet to do our result and get and compare. Yeah, this chart. Yeah. So the source is GBD 2016. Yeah. Well, but ideally, even World Health Organization data show almost the same. The reason to this is very easy, because we use traditional biomass, and the type of our kitchen, you know, the smoke cannot let out. So and that's actually the aspect of the black carbon of the soot or the smoke, yeah, within a small confined area, and you are exposed there for a very long period of time. So the deaths are more than the dispersed emissions in the ambient air.
Oh, thank you very much. So the last one, so that we can move to the next session. Perhaps I saw that motorcycles are one of the largest contributors to PM 2.5 and even black carbon. And we know that the number of motorcycles have increased just in the recent years. Perhaps this was not the case maybe 10 years or maybe 15, 20 years ago. And now we see this as a very, dire situation, which is really exposing both the human health as well as the environment to pollution and, the negative impacts accompanying this. So in your view, what do you think should be done? Because I think when you hear about motorcycles in Kenya, you just fear because of the pain it has exposed to people, even on those who are driving on the road. Much of the time is the pain in the wrong place. In your view, what do you think should be done in order to contain not only maybe the problem of pollution, but also the increasing number of motorcycles?
Now, one, it's, well, there are so many policies that are there within the Nairobi metropolitan, including the non-motorized transport system, using bicycle and walking. So this is a policy that has been there since 2015, the NMT policy. And this could be one way of reducing this emission. The only problem with it is our nature, maybe the places we live and where we work. Most of us live outside in the outskirts of Nairobi, or within the estates which are very far off the city where we work. Yeah. So in this case, we still need drive or to travel to where we go to work. So because motorcycles, we cannot say that we'll remove them, but we could propose efficient types of motorcycles or alternative motorcycles like the scooters that use electricity, because most motorcycles either join us between one near point. They are not very far distance, yeah, but there are so many. Yeah? So the electric motorcycles, there are so many that could cover those distance and recharge them quite often. And that could be a way of reducing the emissions from the motorcycles, just replacing the type of motorcycles that we buy on the market.
Thank you very much to you, Mbeo, for your presentation and all the responses you've given us. I believe we are very well versed now with issues, vehicular emission, as well as the work you're doing at the Stockholm Environment Institute. And we hope that we can continue working together even after this. And allow me now to welcome Professor Michael Gatari from the University of Nairobi Nuclear Institute for Nuclear Science, so that he may give us the next talk. And karibu sana, Professor Michael.
Thank you very much, Richard. I haven't used Zoom so many times, but let me see what I'll be able to project. And I'm happy you brought me in a circle where I have seen Jane for many years, after many years. I've also seen Modama, who is, I think, is on vacation, and yeah, and many others. So those I have seen ones. The problem, is anything coming that way?
Yeah, at the bottom of your screen, if you can share, I can see something coming. Yeah, sure, it is there.
It is there. So I don't know.
So you'll only blow it out so that at the bottom.
Yep.
Yeah, exactly there.
Will it really help? I wanted. Oh yeah, fine.
Yeah, sure, exactly. That's where we are now. Great.
So, well, I thought I could just talk a bit about black carbon and what we know, but I should have written what I know here, because I can see there is a lot of people who know much more than I do. But mainly, one thing I would say is that we know nothing. I know nothing about hydrofluorocarbons, because most of these species, as you know, they are quite expensive even to do measurements and analysis. And the handicap we have in the Sound is the infrastructure for studies. While we have a strong human resource which can be trained and promoted to understand what happens, we still are suffering from the lack of infrastructure. And obviously, even if you get an equipment which is expensive, the operations becomes now another challenge and maintenance. Well, yeah, most of the time, excuse me, because most of the time I forget acknowledging when I'm tired by the end of the presentation. So I better acknowledge Richard and his group, and of course those who are putting some parts to have this webinar. It makes me feel very good, because we have been struggling to see activities on air pollution and specific air quality in the perspective of human health done by many people. But now I can see a large group of people interested. And I can't forget the International Science Program of Uppsala University, of which I don't think I'll be here if they have not been supporting the Institute of Nuclear Science. And obviously my global network and colleagues. Well, I don't need to go too much on this, but at the end of the day, when we talk of most of the air pollution started in the area of implications in human health, and mainly the implications in the respiratory system. And the smaller the particles are, the more inside they go. And they are able to go into interfere with the oxygen exchange, and this is well known knowledge and can also be scooped from literature and other fields very clear. But this is the basis of the criteria pollutants, how they came about many years back. And I would also mention here is that the high level of provocation on air quality measurement and studies was a 1952 problem in London, where over 4,000 people died because of air pollution. And there was high levels of burning of coal at that time. Well, this is an old diagram. I think they are better ones, but it gives the image of why air pollution also has high levels of implications in climate variability, climate change, or whatever you call it. But I like saying climate forcing, where the sun is the driver of life on the earth, and this is well known in the meteorological circles and many other areas. And the impact of air pollution when they interfere with this also have implications in climate variability. And this is a scenario we are very much aware of. And those buses, most of them are on diesel. Some are even highly smoking. Some of these private vehicles are also, they smoke very highly, and you can see here. You can see my friend here is right at the pipeline. The other guy is jogging, and there is also a news bidder. So you can see, irrespective of how we look at it, even if we didn't know science, there is implications of health problems on that. We are also people who are used to burning rubbish, like this big site we picked up, smoke we picked up was burning of tires. Unfortunately, I'm having a problem of faster agreement. I think my compatibility is this, but it doesn't matter. I think it's a Zoom program. So those are the kind of things we have. There is bad waste management, and therefore excessive air pollution, and irrespective of the transport, there is side waste management. And the burning of waste is very common. And this is why I could have, I wanted to mention during Professor Mudama's presentation and the amount of black carbon he was talking about. Part of it definitely in July comes from this waste management burning because of the temperature impact. The temperature goes down, people are cold, and they start burning on the streets everywhere. In houses, more burning of fuel for warming comes in. And this is one of the sites we have used for many years at the university for measurements, but note that site is at 17 meters above ground level. So some of the results you see, I'll mention are from 17 meters above ground level, but we are coming up to how we can now estimate what will be the problem on the ground. And I think it's better when I come from there to mention a few studies, not many studies, because I thought there is the limitation of time, and also if you talk too long, people lose what you are talking about. So from that site, which is about, for those who know, University of Nairobi is about the Department of Electrical Engineering. We are changing it now to another for other measurements, where we want to bring other instrumentation with another project with one of the deputy vice chancellors. So I started with Gaita et al., where I was involved also. These are some of the measured results through, we use the gravimetric measurement for this one. So they give reasonable information for not only for both for air quality or human health implications, and also obviously whatever is being emitted, it also goes into the atmosphere. And this was PM 2.5, particles less than 2.5 diameter, aerodynamic diameters, because there are many types diameter focus when we start talking of aerosol technology. Later, the measurements were done both at that site I have shown you at Nairobi University, and thanks to Jane at UNEP, we were able also to measure at around near the same height over at UNEP, which we consider as the background. At the same time, this measurement is the longest measurement to my knowledge, which I know of, because you can see it started around 2008 all the way to 2010. Obviously not every day, but it's truncated, but it's the longest measurement because most of the ground measurements are hampered by cost. It's expensive actually to learn ground measurements. Besides the cost of instruments, there is also the cost of operations. And if you can see, there is relatively an average of about 20-25 micrograms per meter cubed. There is also a variation over the years, or over if you consider a whole year, there is variation. Unfortunately, this the number of days, many people are not used to Julian days, but many people in the meteorology fraternity, they understand what this is all about. But that's not important. The important thing is the variability of this over the year and the kind of concentration we are talking about. And at 17 meters above ground level, which is within the regional now info. So this has a 25 microgram per meter cube. The implication on the ground is nearly 2.5 times the 25 microgram per meter if you are measuring on the ground. And that I can only say that for Nairobi, the Nairobi measurement site, not for UNEP site, because that would have a different way of estimation. Now, at least this study is published. This data which is here is not published. You all know most of the hydrocarbons are part of the particulate matter, and especially more so for aromatic hydrocarbons, bit of chemistry here now. And some of the polyaromatic hydrocarbons are known to be carcinogenic. You also know in Kenya, and especially in Nairobi, with the few data we have, or assessed the data on cancer cases, they're increasing. Part of these polyaromatic hydrocarbons are known to be carcinogenic, and they are accepted by international IARC as causing cancer. And you can see the kind of concentration, though in nanograms, they are not small, and there is no known limit which you can say you are free from being infected. And therefore, in Nairobi, there is this threat, and as Beo said, until the public sector, the public health sector and the medical fraternity really get involved in these studies, it will be very difficult to really tell the implications. But of course, we have the knowledge to know that there is health implications from what is being emitted from vehicular emissions. Because most of black carbon is actually together internally mixed in particles with hydrocarbons. So wherever you see for the aromatic hydrocarbons measured, obviously you expect there was black carbon. And this, I have just listed the, I've just listed the number, some of the species which are polyaromatic hydrocarbons and which have implications in human health. I've also commented on what, if we had the actual proper infrastructure, how we can tell whether some of these polyaromatic hydrocarbons are from domestic combustion or they are from trafficking. but the investment is for sure high in laboratories, and the operational cost is another issue. So it's one thing to request for an equipment, it's another thing to think on how you can continue the operation. Now, there is another study here, Kinney et al. 2011, it's already published. We did this study in collaboration with the Columbia University Sustainable Development Group, and Kinney was a part of it. And if you can see here, we did it around Tomboya Street. There is River Road and Ronald Gara. We had also part of it at the university, and if you can see, this is an older map because this roundabout no longer exists. And we were able, actually to get ground data because we had FADs where we put in a lot of many graduate school on the streets for 8 hours. We even facilitated them with milk and all that because they were also exposed, and we made sure they were changing. They had the personal samplers on filters, and they were also changing after every 2 hours. They were giving each other. So it was quite an intensive study. It went for 2 weeks. And we came up with a very interesting result because it is from this study that we are also able to, it was from this study around this area here that we were able to do vertical assessment of the pollutant distribution. And also we did a horizontal distribution of particles from here. If heavy particles are emitted from the road here, how much do you get when you are inside the field in the university site? And that study is a study you can go and get it from the internet. And what we had is that in Tomboya Street, you can see this color is the mean concentrations, and this data is for 11 hours, 10, 11 hours. So the area is not 24 hours for comparison with the standard. But what it is, through the vertical distribution study we did, we were able to estimate that within these concentrations will come down to about 45 micrograms per meter cube on the roads, which is far above what the recommended guidelines by World Health Organization. Our local standards, well, it's a different case altogether, but internationally, obviously, we are far above. I also want to mention that we also went further and did some, you can see the comparison here with the rural sites, which is very low, near zero, which was in the compound of Kenyatta University. Now there is also, we also try to estimate the driver consumption of this particulate matter. We had driver A in a different load and driver B, and you can see driver B was exposed much more. You can see the amount of black carbon, because black carbon is entrenched in particulate matter. It is high in particulate matter of less than 2.5 micrometer diameter, aerodynamic diameter. So, other than that, there is this unpublished data. There is this unpublished data. It also shows you the gaseous species. Although we didn't, the data is not published because it was the limited period and the problem of the instrument, because we had an automatic instrument which failed in the course of the measurement. But at least this gives you an indication that all is not well, because this is at the same height, 17 meters, the gaseous pollutant. Obviously, you expect the regional input, But most of it, because we are within the boundaries of the central business district of Nairobi, definitely transport has a high impact. And you can see the levels of ozone. Although here the atmospheric chemistry or the tropospheric chemistry, also the volatilization of NOx and formation of ozone, and also the and also the sorry for this, volatile organic carbons, all these combinations, when you have hydroxyl radicals in the same system, there is quite a lot of hydrocarbon breakdown, which comes probably into methane levels and so forth. But these are studies which should be done more comprehensively. They require more investment for understanding to be done. But the main point is for the climate implications, you can see even cities, Nairobi and the major cities with high traffic like what we have very serious implications on climate variability. And yes, this is another study because I think somebody mentioned that indoor air pollution could have a lot of complication, which is true. And this is a study of one of the PhD students. He's already on a draft paper. She was one of our students, and now she's pursuing her PhD in Italy, called Mutai et al. And the idea here, why I brought this one here, is that the indoor in urban centers is not as high. You can see we are heading to very high particulate matter concentrations in the rural homes, because this is indoors, and especially when the temperatures go down, the warming, you close the windows so that it is warmer, but then of course you close. But this is not what you can compare now to the standards, because it was only during daytime, it was not going for 24 hours. And therefore there has to be a method of estimating what would be expected to be for 24 hours. What is the consumption? Because obviously this is mainly when the cooking was going on during daytime, and in the evening, in the morning, and lunch hour. And then most of the families do not stay in houses, whether it is cold or not, even during July. So those are some of the studies and the information we should be, and probably when Mutahi's paper come out, it will expound a bit further the science behind it. But these are the two. The out is the ambient. This is indoor. This is ambient concentration, which are flagged from other short studies. And you can see they're in the region of 100. And this, I think, was picked from calibrated data from what they call low-cost monitors, which I think they are low-cost in the north and not in our environment. So those are my opinions. Now, I brought this because this is a pilot study we did around university and Uhuru Highway, just around the university roundabout and so forth. And some of these, like benzene, toluene, and so forth, they are all hydrocarbons, but now this is a gaseous aspect, and they are also highly carcinogenic. And we compared with what has been measured in Los Angeles, London, and you can see the concentration. But this is a short study. It's also not yet published, but it's the process of being published. The pilot study and a collaboration between us and Lista University of Lista Chemistry Department, because they have the facility to analyze this species and many more. But you can see the kind of connections we are doing. it implies we need more investment. It implies there is a lot of air pollution we are contributing in a global climate variability system. Now, this another one where we have PM 2.5 and black carbon, and this is not very old data. You can see that, and it's not yet published. This is my data, and it is the process of being published. But you can see it's a whole year measurement, same site. But this now is brought down to the implications now are such that the black carbon is not small amount all the way through. So the contribution of SLCP from Nairobi is not small, and as vehicles were shown to increase, is not going to be any better. There are other studies which I did not bring here, which shows even worse cases, because there was some work I did on Mount Kenya for the UNEP scientific group. It also showed a lot of black carbon at Mount Kenya, and the only way, because it was the high altitude at nearly 4,000 meters, it meant that the contribution from the regional aspect is very is impacting on that region as well. But then the weather systems have a lot of implications on what you, like Professor Modama said, on what actually you observe. And there is no data which can make sense without having parameters like creat, temperature, and all these weather parameters. And from there, I can say thank you very much. I know I haven't given as much as I have, but that actually gives you the motivation towards the future. Thank you.
Thank you very much, Professor Michael. We really appreciate your presentation. Perhaps we could just get just 1 minute question, because time is really against us, so that perhaps if we have somebody who really feels that they have a question that should be answered right now, please provide that right now. I don't see any question from the Q&A, but if we have any panelists or our attendees, just the very first one is the one I'll give the opportunity before we go to the close of this session. Well, silence means that we are quite hungry, but then the Q&A and also the chat space, you can always post your question there. It can even be answered after this particular session. But allow me to thank each and every speaker, panelist, Professor Michael Gatari, Jane Akumu, Professor Mudama, also Mbeo Ogea, and also let me appreciate Ruth Sego. She is actually she's a senior program associate at Climate Works, actually the foundation that has funded this project, and we are really appreciative of that gesture. And also let me appreciate Dr. Charles Keegan from our university, who is also part of the project team, and also Dr. Charles Mutai. And generally the Kenya short-lived climate project team, which includes the Council of Governors, representatives from the civil society, as well as Joyful Women organization, which is represented across all the 47 counties. I also wish to passionately congratulate and also thank all the attendees. Most of them also came from the Kenya Met Society. They are all professional scientists, and we are really glad that you could join us. And now we will proceed and close this session, but the discussions are not closed. we'll still continue debating. I believe you found it interesting, a lot of new information, and we cannot stop at this. So I'll be in touch with our speakers, our panelists. Thank you very much.